Why is the product of two positive integers equal to their highest common factor HCF times lowest common multiple LCM? Today, we are going to break down this relationship step by step, so by the end of this video, you will see exactly why it works and how to prove it. Our formula says that for any two positive integers, their product A times B is equal to their HCF times their LCM. This formula works because HCF and LCM capture all the factors of both numbers without any gaps or overlaps. Let's see why that's true with an example. Let's take our numbers A equals 12 and B equals 40 and go through each step. First, represent the two numbers as a product of their prime factors. I'm using the upside-down division method, but the prime factor tree diagram is another great method you can try. To find the HCF using prime factors, multiply the lowest power of each prime factor common to both numbers. In this case, 2 is the only common prime factor, and 2 squared is the one with the lowest power. To find the LCM using prime factors, multiply each prime factor with the highest power. In this case, 2 cubed, 3 and 5 are the prime factors with the greatest power. So, the HCF times the LCM is equal to 2 squared times 2 cubed times 3 times 5, which can be rearranged to show that it is equal to 12 times 40. Hence, 12 times 40 equals the product of their HCF and LCM. Let's take another set of numbers A equals 720 and B equals 3,500 and go through each step. First, represent the two numbers as a product of their prime factors. Now, find the HCF by multiplying the common prime factors, taking the smaller power of each. Then, find the LCM by multiplying each prime factor that appears in either 720 or 3,500, taking the larger power of each. Next, it can be easily shown that the product of the HCF and LCM is equal to 720 times 3,500. Alright, so why does this formula work in every case? Let's go through an algebraic proof using prime factors. Let A and B be two positive integers. HCF, A and B in brackets represents the highest common factor of A and B. And LCM, A and B in brackets represents the lowest common multiple of A and B. Let the prime factorization of A be P1 to the power of H1 times P2 to the power of H2 times P3 to the power of H3, and so on, up to Pn to the power of Hn. And let the prime factorization of B be P1 to the power of K1 times P2 to the power of K2 times P3 to the power of K3, and so on, up to Pn to the power of Kn, where P1, P2, P3, and so on, up to Pn are the prime numbers that divide A or B. And Hi and Ki are the exponents of the primes for A and B, respectively. Note, if Pi is not a factor of A or B, then Hi equals 0 or Ki equals 0, making Pi to the power of Hi equals 1 or Pi to the power of Ki equals 1. The HCF takes the lowest power of each prime factor that appears in both numbers. LCM takes the highest power of each prime factor that appears in either of the numbers. Next, find the product of the HCF and LCM, and then simplify it using the indices laws. After that, find the product of A and B. By simplifying it using the indices laws, it can be easily shown that it is equal to the product of their HCF and LCM. So, using prime factorization, we've shown that the formula A times B equals HCFAB times LCMAB holds for any two positive integers A and B. To wrap up, this formula shows a powerful relationship between multiplication, common factors, and common multiples. It works because the HCF and LCM together capture all the prime factors of A and B without duplicating or missing any. That's the bell. Thanks for watching. If you found this helpful, please like, subscribe, hit the notification bell, and leave a comment with any questions. This is Mr. K's Simplified Maths, making maths simple and fun. See you in the next video.